All right, this is Math 1, Unit 1B, Lesson 7, Practice on Solving Multi-Step Inequalities. All right, so here we go. This is something you worked on actually a lot in 7th grade, a long time ago. So let's work on this together. To do this here, it's not much different than a regular kind of equation you're solving. If this was an equal sign, we'd move things around, and the goal is to get the m, the variable, isolated or by itself. That's our ultimate goal here. The only difference is now you're working with a greater than or less than sign, and sometimes less than or equal to signs, which will change one step of what we do from time to time. And the key thing is that if I divide by a negative number, any kind of negative number, then I have to flip the sign. I have to flip the inequality. That's the big key in the whole deal. That if you forget that, that's going to be an issue. So when I divide by a negative number, I have to flip the inequality sign around the other direction. Other than that, it's very straightforward. So let's take a look here. We're going to begin with, first of all, moving the whole number. So I'm going to subtract 12 from both sides. So that goes away. 24 minus 12. This 3m stays here. Just bring it down. That inequality stays less than. 24 minus 12 is 12. So I'm just moving it down. Now I need to divide both sides by 3 to get the m by itself. It's a positive number, so I don't have to worry about this little rule. Everything stays the same. So 12 divided by 3 is 4. Oops. Sorry about that. And I'm all done with number 1. Just like that. Okay? Alright, that's all there is to it. Now if I was to graph this here, what we're saying is that if this is 0, 1, 2, 3, 4, we're saying that m could be anything less than 4. So here is less than. I draw an open circle because it's not equal to. And it can be anything less than 4. That's the idea of what we're saying. That I can put any value in that spot less than 4, and this will be okay. Let's look at number 2. First of all, I'll add 3 to both sides. So we add 3. When we bring this down, we have 4w is greater than or equal to 33 plus 3 is 36. Nice numbers we're working with here so far. We divide both sides by 4, so a positive number. So the w is going to be greater than or equal to 36 divided by 4 is 9. So in this case here is 9, here's 8, here's 10. W can be any number greater than or equal to, so we have a whole circle, 9. So if we graphed it, it would look something like that. Number 3. I'm going to add 2 to both sides. So now I have 2p is less than or equal to negative 14 plus 2. The signs are different, so I find the difference. 14 minus 2 is 12, and I keep the one with the greater absolute value, or the bigger sign, which is negative. So I have negative 12. I'm going to divide by 2. I'm still dividing by a positive number, so this stays exactly the same. P is going to be less than or equal to negative 12 divided by 2 is negative 6. So if I had negative 6, 0 on a number line, P is going to be less than or equal to, so that's a whole circle, negative 6, like so. Number 4, same idea. Let's go ahead and subtract 60. Subtract 60 from both sides. So I have a positive and a negative, so those are different. So I'm going to find the difference. 60 minus 12 is going to be 48, but I keep the bigger sign, so I actually have negative 48 is greater than negative 6t. Now for the first time, I'm going to divide by a negative number. And again, the rule was if I divide by a negative number, negative, I need to change the direction of that sign to this. 48 divided by a negative 48 divided by negative 6 happens to be a positive 8. We don't always change the sign here, so be careful. This just happens to be a negative by a negative. That has nothing to do with the rule. The rule is just about what happens to this inequality, changing the direction there. That's just a regular division rule. Negative divided by negative is a positive. Okay? And then over here, that cancels out, so I'm left with just the t. Alright, so x is going to be, or t is going to be anything, t is going to be greater than 8. So make sure you read that the right way. Here's 9, here's 7, and open circle because it's just not an equal sign. So t is anything greater than 8. If you wanted to write it the other way, you could write t is greater than 8 if it helps you read it out better, but that's the same thing. Okay, let's look at the ones down below. Again, same idea. We're still solving inequality, but a few extra steps. Now I have to begin first of all by distributing the 4 through that part there. So I have 4k, 4 times 2 is 8, and I have the minus 3k, it's less than or equal to 12. Next step is to combine like terms. I have a negative 3k and a 4k. That will combine to give me just 1k. I want to move the 8 over here. So to move it over there, I subtract 8. Instead of a positive, I have a minus. So 12 minus 8 is 4. And my sign will stay exactly the same. And I'm left just like that. K is less than or equal to 4. Number 6. Distribute. 3 times 2 is 6c. 3 times negative 2 is negative 6. And I have a negative 2c is less than 0. I'm going to go ahead and combine like terms. So here's a negative 2 and a positive 6. Those will combine to give me a 4c. And if I add the 6 over to here, 4c is greater than 6. Divide both sides by 4. And then c is greater than 3 over 2. And we can leave it just like that. I don't have to go any further unless I really wanted to. Okay? So that's the idea for numbers 5, 6, 7, and 8. Let's look over the back side. On the back side, we're going to solve inequalities and try to solve this and decide if the solutions are all real numbers or if there's no solution, what it might be, and we'll kind of see. So let's take a look here. If I distribute this out, I have 8w minus 5 is greater than 8w, and then this becomes 2 times 3 is negative 6. Now, what makes this a little weird is that I have an 8w and an 8w, which means if I subtract them, I have no w, right? So that's not going to work out very well, is it? If I solve this here, I'm going to say, well, if I subtract 8w from here, subtract 8w from there, not dividing, subtracting, I have 0w. So I have 0w. If I add 5 and add 5, on this side I'm left with negative 1. So I end up with 0 is greater than negative 1. That's not going to work really well, is it? I mean, I'm going to have a problem with that to make that work. So I don't really have a solution on this one here. What's weird is my answer key says all real numbers, but I'm not sure if that's actually going to be right here. So let's take a look. So w, let's say it's 1. Let's pretend it's, well, let's pretend it's 0, because 0 is a real number, right? If it's 0, negative 5 would be equal to greater than, let's see, so 0, was 0 greater than negative 1? That's true. So this is actually a true statement. If I had 0, I would do 8 times 0 minus 5 is greater than 2 times 4 times 0 minus 3. Right? So you end up with negative 5 is greater than, and we multiply that, that's 0, and negative 6. Is negative 5 greater than negative 6? Yep, that's true. So, because it actually works out as being a true statement, then our answer would actually be, like it says, all real numbers. So it sounded a little confusing at first, but it's good to plug a number in and say, well, why is it saying that? Is that what it was? What does it mean? And the answer is, because it would work for all real numbers. It would actually work out to be something that makes sense. 0 is greater than negative 1. Even though we lost the variable, it's still a true statement. That's still a true statement. Let's look at this next one. Let's see if it's any stranger than that last one. So here we have 4r plus 15 is greater than or equal to, distribute 4r, and then we have 4 times negative 2 is negative 8. Okay, well, if I take a look at this one here, I go, that's not going to work very well. In this case, I'm not sure what they want me to do because it's just not going to work out. What's weird is that in my book that I'm looking at here, this number here is actually negative 3r. So I'm not sure if that should have been changed to give you something different, but that's what the book I'm looking at shows me, even though your work shows you this. In this case, these cancel out, and we say 15 is greater than or equal to negative 8, which is just like the last one, all real numbers. So, kind of strange, not quite sure why that's like that, but we'll go with it. All right, let's take a look at one of these word problems here, and then we'll be done with it. A grandmother devises an inequality to help her remember the ages of her 2 grandchildren. She knows her grandson is 2 years older than her granddaughter. Okay, so let's call him grandson. So the grandson is going to be the granddaughter's age plus 2. Okay, and that together they are at least 12 years old. Okay, so the grandson is going to be the granddaughter plus 2. So granddaughter plus 2. So, and together they're going to be at least, which means at the least amount, 12 years old. Okay, so when you combine those things together, you find out they are going to be at least, which means they're going to be greater than 12 years old. Now, my variables aren't working too well so far, but I just wanted to keep track of what I have here. So, if I take the granddaughter's age, let's call her X, right? X, and we call her X plus 2. That's the granddaughter. So actually what I want to do is say the grandson is actually X plus 2. So it's because my grandson's age is X plus 2, and the granddaughter is X. So I take the granddaughter, her age, and I add to it her own age plus 2 for the grandson, and that's going to be at least 12. So when I work this out then, what I'm going to say is I have 2x plus 2 is greater than 12. I subtract 2 from both sides, so 2x is greater than 10. Divide everything by 2, and x is going to be greater than 5. So it tells me that the granddaughter, who is the x, has to be at least 5. So the granddaughter is greater than 5 years old, which means the grandson is going to be 5 plus 2, right, is going to be greater than 7. That's kind of your basic way you look at that there. So I know my words didn't quite make sense, but I worked them out at the end. So I just find it's just helpful to write things down and kind of shorthand it to say, what am I talking about here, to help solve it out. All right, I'll stop there for now. Hope that helps a little bit with your homework. Good luck.